Hello, this is Greg Monty, and this is the CERT educational series about heat transfer and the heat transfer module. This particular video is about enrichment and covers the basics of heat transfer. Let's start off talking about ice and water. Why does ice melt? Let's say we start with a glass of 21 degrees Celsius water and some ice cubes. The temperature of that tap water, as I said, is 21 degrees Celsius, and the temperature of ice is about 0 Celsius. If we put that ice into the cup with the tap water, what will happen when the ice is added to the water? Well, we all know this because we've observed this hundreds of times. The ice melts, begins to melt, and then ultimately will completely melt. But the question is why? And the answer is, as we learned in the heat transfer module experiments that we did, there's a temperature difference between the two bodies, so the warmer body gives up its heat to the lower or cooler bodies. So what happens to the temperature of the water? We know this also because when we put ice into water or into tea, we know that the temperature of that liquid goes down from experience. But again, the question is why? And again, just as we learned in the heat experiment, we learned that when heat leaves a higher temperature body and goes to the lower temperature body, the heat leaving the body causes the temperature of that body to decrease. So the water, starting at 21 degrees Celsius, decreases in temperature as it gives up its heat to the ice. Now let's think about hurricanes. What happens to hurricane strength when it crosses warm water? We know from experience again that it picks up heat energy from the water. The storms that start in the Caribbean are over very warm water, and that's where they pick up their strength. This happens because there is a temperature difference. Warmer water and a colder hurricane above in the air. So the warm water is picked up by the hurricane, and it produces additional energy for that hurricane to build its strength. So what happens to the hurricane strength when it goes over land? Well, we also know from experience that it causes it to lose energy from cooler and drier air over land than over water. So let's think specifically about Hurricane Matthew from 2016. You can see a map on the right-hand side showing the progression of that storm that started around September 28th in 2016 and finally left the coast of North Carolina as a low-temperature tropical storm on October 9th. So let's think about the transition of that storm from its inception to when it moved back out to sea. What happened to the strength of Matthew when it was in the Caribbean? Well, it started as a tropical storm on September 28th and grew to a Category 1 storm on the 29th, and further increased to a Category 2, 3, 4, and 5 in one full day. And on September 30th, it was a Category 5 storm, still over water in the Caribbean, picking up lots of energy. And then on October 1st, it began to decrease a little bit to a Category 4 and move towards the north. It kept its Category 4 strength all the way until it reached close to Florida, where it decreased to a Category 3. So the answer was, when it was over the Caribbean, it was gaining strength all that time. From a tropical storm to a Category 5, decreasing just slightly to a Category 4. Then what happened as Matthew moved north to Florida? Well, eventually, Matthew got close enough to Florida, and the temperature of the waters are now decreasing as it moves further and further north. So as it did, it decreased its strength as it got over colder waters. And what happened to the strength when Matthew hit land in South Carolina? Well, it was decreasing from at least two different reasons. One, the temperature of the waters were decreasing more and more as the storm moved towards the north. And secondly, it went over land and therefore picked up cooler air into the storm. And that caused the storm to quickly diminish from a Category 1 to a tropical storm and move out to sea. So it really did lose its strength down to a Category 1 when it struck land. Let's think about a pool. What happens when you jump into a pool? What does it make you feel like? You feel cold. Again, the question is, why do you feel cold? Well, by now we should all be answering the same thing. We know that heat flows from your body to the lower temperature pool water. Remember, your body is about 98.6 degrees or 37 degrees Celsius. And the water in the pool is certainly not going to be 98 degrees. Or at least most likely it's not going to be, unless it's a hot tub. So if you get into the water, you're a higher temperature body, the water is a lower temperature body. Your body gives up its heat to the pool water, and therefore you giving up heat make you feel like you're getting cooler. In fact, you indeed are getting cooler, and it decreases your overall body temperature and you feel cold. Have you ever put a cold cloth on your forehead because of a fever? And why would you do that? Well, it's the same reason. The temperature difference allows heat from your body to transfer to the cooler cloth, thus reducing your body temperature. Probably sitting in a bath of ice water would be even better. So what about climate change and the impact of storms? If climate change makes the ocean warmer, which is what we're measuring on Earth today, then the temperature of the oceans will rise. If the temperature of the oceans rise, that warmer water will effectively have more heat energy in it. And therefore, what do you think will happen with a larger temperature difference between the oceans and the air, or more heat energy in the oceans? Well, stronger storms are going to be expected. Alright, so when you think of other examples of heat transfer, let's make a list of examples of heat transfer at your tables and label them as either conduction, convection, or radiation. Let's look at a few examples first. Heating a pot of water on a stove is conduction, convection, and radiation. Cooling of the body by sweating is a form of radiation. Heating of buildings involves convection, and some radiation from sunlight and some radiation of heat to the outside. Cooling of buildings is typically convection, and melting ice or boiling water is convection and conduction. So multiple forms of heat transfer are involved in many different aspects of life that we experience on a daily basis. Let's continue with some more examples. Shivering when cold, heat from a car engine, sun warming of the earth and weather, burning of fuels or explosions, ironing a shirt or drying clothes, or roasting marshmallows on a campfire. All examples of heat transfer. So why don't you at your tables take some time to talk about heat transfer and come up with an example from each group to share with the rest. Thanks for participating. This is the CERT educational series and a continuation of the heat transfer module. And today we talked about some of the basics related to enrichment of the heat transfer concepts. Thank you.